Okay, we'll get started in about a minute. In about a minute, we'll get started. All right, here we go. Review number two. Review number two. The test is tomorrow. I'll have it posted by 7:30 in the morning. You can take it at your leisure. I do not want, no calculators, right? If you put a calculator answer, you're wrong because your calculator is going to write it as an irrational number, an approximation. I want all the square roots simplified, which is why it says simplified right here. So don't even think about using your calculator. It's going to tell you not what I want. Just like yesterday or the last review sheet that we did on the video, it's the same thing here. I'll go over every single section here. You can ask questions right now. Ask me to do more. I'm not going to, I'll talk about every question, but I'm not going to solve every question. So let's just get started. The first thing on your test, by the way, there will not be this many questions on the test. It'll be, I don't know, I haven't made it yet, but it'll be 20 to 25 questions on the test. So the first section just simply says to simplify. So as always, you should have your perfect squares written. Well, you don't need to write one, but let's see. 2 is 4. 4 is the perfect square. 3 is 9. 9 is the perfect square. 4 is 16. 16 is the perfect square. 5 is 25. I'm not going to write all of these down. I'll write maybe the first 10. 6 is 36. 7 is 49. 8 is 64. 9 is 81. And 10 is 100. So these are the numbers that I wrote 100 instead of 10. 10 is 100. All right, so these in the second column are your perfect squares. In the second column in blue, those are your perfect squares. These are the numbers that I'm thinking about when I simplify. Now, the first column there, that's the square root of those perfect squares. So on our first one right here, we had the square root of 63. We ask ourselves, which one of these numbers in the blue rectangle goes into 63? Well, you can start with 4. 4 doesn't. 9. Yeah, 9 does. So we write 9 times some number. 9 times what? 7. I don't need two numbers from the blue box. I just need one. Sometimes there will be two, though. So the square root of 63 is 9 times 7, and that can be written, this is an extra step, as the square root of 9 times the square root of 7. And then you can take each individual square root. The square root of 9 is 3, right? And the square root of 7, there's no answer to that. So that is your final answer. Do you need to write those middle steps? No, you can literally go from there to there if you know what you're doing. What would I recommend? I would recommend the first two steps. Clearly, that would show me, in case you make a silly mistake, and you write, I don't know, 6 root 7 instead of 3 root 7, that you knew that 63 was 9 times 7. If you just go from square root of 63 to 3 root 7, okay, that's fine. But if you make a silly mistake, I can't give you any credit for, trying because I can't tell what your thoughts were. So I would recommend these first two stages. You don't need to put that other one. All right, I didn't say we were going to do all of them. I said we would do some of them. So anyone live want to pick one that you want to see? Or I will pick one of the two. Either you pick or I pick. All right, I guess I'm picking. Well, 2 looks like it's challenging because it's huge. Well, let's do 2 then. All right, 2. Well, 2 isn't really that bad because notice that 640, inside 640 is a 64 at least, right? So that could be written as what? 64 times 10, right? That would be 640. Square root of 64 is 8, so that's, this one isn't much going on at all, just 8 root 10. There's no perfect square inside of 10. Equals, this is your answer. Questions. I said I wasn't going to do all of these. I'll have some that'll be oh, I didn't want to do that. I'll have some that are perfect squares. I mean, like literally it'll be the square root of 36 or something like that. But most of them will be like this one. So for instance, the square root of 36 obviously is 6. All right, any ones that look more interesting? All right, let's try this one, number 6. All right, this is the first one that's a little bit stranger. I'm going to ignore that number out front to start with. I'm still going to put it there, 112. So here now comes who can do factors the quickest? Well, 4 does go into 112. Is there a larger number? Give it the old 10-second thought. And if nothing strikes you, just stick with 4. Maybe you have to do 2 or 3 steps, but maybe that's the only answer. But if you spend 4 minutes trying to figure out the biggest number that goes into 112, that's in that blue box, when you knew that 4 did, then you're kind of wasting your time. Let's see, 4 goes to 112, what, 28 or 28 times. 28 times. The square root of 4 is 2, and 2 times 9 is 18. So I get what? 18 root 28. And now you can kind of see, oh, check it out. There was probably 16 went into 112. We just didn't know it. Why 16? Because I can pull out another 4. Because I can write 28 as what? 4 times 7? 4 times 7. Stop me if you're lost. The square root of 4 is 2. 2 times 18 is 36. So 36 root 7. If I had known from the very start that I could write that as 9 root, 16 times 7. 16 times 7 is 112. Then I could have done this in one step. Square root of 16 is 4. 4 times 9 is 36. How many of us are going to realize that 16 went in there? Don't include me because I didn't. Like I said, don't panic if you got to do multiple steps. You still get exactly the same answer. And we didn't do that many more steps, right? One extra step. Okay, questions. This is one of those tests where you can almost guarantee you're either going to make an A or an F on it, right? If you know what you're doing, it should be an easy A. If you don't know what you're doing, there's no chance the math fairy is going to come and sprinkle math dust on top of your head and you're going to figure this out on test day. So please ask the questions. Do any of these look complicated? Maybe 196 or 96? I don't know, either one. Let's do this one. So 5 root 96. Once again, give it the old 5-minute thing. Let's see, what goes into 96? Well, I know 4 does. Does 36, 72? Nope. I'm thinking it's either 16 or 4. Let's try 4, see what happens. 4 times what? 24. Yeah, it turns out that it's going to be 16 goes into it again. Square root of 4 is 2. 2 times 5 is 10. So we get 10 root 24. I mean, don't panic. I mean, you do this enough, maybe you'll start seeing some of these, but 16s are hard. And I can write that as what? 10 times 4, so the square root of 4 times 6. So it turns out 16 did go into it. Square root of 4 is 2. 2 times 10 is 20. So it's 20 root 6. I mean, literally, this is how long it should take you. It shouldn't be that long of a process. If you sit there forever and you're trying to say, does 16 go into it? And you're just spending a lot of time thinking, 16 goes what? 6 times? Yeah, 6 times. But square root of 16 is 4. 4 times 5 is 20. So we get 20 root 6. Same answer. That's a 20, not a 26. Oh, so if e-learning continues, boy, do I need to get a tablet and a pen. Writing with your finger on a mouse pad is just not very good. All right, so 20 root 6. Either way is fine. Questions before we move on to the next section? Any questions? All right. What's in the next section? Next section is multiplication. So hopefully you remember the basic rule. The basic rule is outsides with outsides, insides with insides. So let's see. Outsides with outside, inside. 5 times 2 is 10. should put an equal sign. Square root of 12 times the square root of 12 is the square root of 144. The square root of 144 is 12. 12 times 10 is 120. It won't always be this pretty of an answer, but when it is, it's nice. And by the way, some of you may have realized that, hey, the square root of 12 times the square root of 12, the square root would cancel with the squaring there, and therefore you're just left with 12. All right, that's that one. Multiplication isn't too hard. I'll leave those up there. Let's see if that'll work. Yeah, let's do this one. All right. Outsides without, no, that didn't work, did it? I need to erase everything here. Outside with outsides, inside with inside. But we got a problem, and the problem is there's no number. Oh, sure there is, because remember, there's a 1 always here. So when we do outsides with outsides, that's a 1 and a 3. And inside with inside, that's a 3 and a 15. Okay. So how does this turn out? 1 times 3 is 3. That's outsides. The inside, 3 times 15 is 45. And it feels like we're done. Except you always have to ask yourself, is there a perfect square inside the square root symbol? And there is, because that would be what? 9 times 5. Right? There's your perfect square. 9 times 5. Square root of 9 is 3, and 3 times 3 is 9. So we get 9 root 5. Okay, that 9 outside isn't because the inside's a 9, but the square root of 9 is 3. 3 times 3 is 9. Questions? Look over those ones for multiplication. Pick one out that you think is challenging. Which one do you think is challenging? Riley, are any of these challenging?
Not really.
Okay. How about some negatives? Yeah, some negatives here. Here we go. I agree, Riley. Outsides with outsides, be careful. Don't drop your negatives. Inside, there will never be a negative on the inside of a square root, at least not until Algebra 2. Okay, let's see. What do we get here? Negative 5 times positive 3 would be negative 15. And 2 times 6 is 12. And then we're back to the age old. Are there any perfect squares inside of 12? Hopefully by now you can do that one really easy. So that would be what? 4 times 3? Yes, our old friend 4. The most commonly used perfect square. Square root of 4 is 2. Don't drop your negative, and you made it all the way this far. 2 times negative 15 is negative 30. So we get negative 30 root 3. The kids in geometry can tell you that this is something that you will use, I don't know, once you get past maybe the 4th chapter. You use this almost every day, that you're going to be messing with square roots. So this will be a very, very, very common thing that you will use next year in geometry, where you have to simplify a square root. And believe it or not, even though we're doing a lot of this by hand, once you do it enough, many of these you kind of do in your head. All right, anyone look interested? This one looks interesting. All right, let's see. Remember, there's always a 1 if there's no number, so that's really a negative 1 that's in front. So let's see, outsides with outside, inside with inside. Now, some of you may ask, should I already see that 12, so I know I can pull out of a square root of 4. Should you do that before you multiply? You can. It certainly would make the numbers smaller rather than multiplying 12 times 5. I'll show you both ways. You can pick which one you think is easiest. All right, if you don't take out a square root of 4 from 12, let's see, outsides with outsides. Negative 1 times negative 2 is a positive 2. And let's see, 12 times 15. Oh, I need some scratch work. 12 times 15. That gives me a 10. That gives me a 6. Bring down my 0, 2, and a 1. So at 180. So I get times the square root of 180. Hopefully you can see that pretty quickly. Maybe not, but certainly 9 goes into 180, right? It turns out that a larger number goes in there. So let's see, pull out a 9. So that would be 9 times 20. So you can see it, there's also a 4. So 36 is the largest number. Usually you get to this step, you're like, oh, it was 36, but you just don't realize it. So just drive on and continue with the process. Square root of 9 is 3. 3 times 2 is 6. So we get 6 root 20. And there's a 4 inside of 20. So that'd be what? 4 times 5. Square root of 4 is 2. 2 times 6 is 12. So 12 root 5. All right, so that was a lot of steps. That was probably the most work we've done so far. What would have happened if we had simplified from the start? So that would be negative 1 times 4 times 3. That would be 12 times negative 2 root 15. All right, well, that just took a lot just to write down. So maybe that's not as efficient. Square root of 4 is 2. 2 times negative 1 is negative 2. So negative 2 root 3 times, stop me if I'm going too fast, times negative 2. Oh, why are you not writing for me today? I know why, because I'm using my finger. Negative 2 root 15. Yeah, this one doesn't save us any time, does it? Okay. Let's see, negative 2 times negative 2 is a positive 4, and 3 times 15 is 45. So it's the same number of steps. In fact, it didn't save us any work at all, other than the fact that you had 180, and this one you got a 45, but it didn't really say, it's the same number of steps. So that would be 4 times, what, 9 times 5? Notice we're going to get exactly the same answer, exactly the same steps. Square root of 9 is 3. 3 times 4 is 12. So we get 12 root 5. We got exactly the same answer. And let's see, 1, 2, 3, 4, 5 to the answer. 1, 2, 3, 4, 5. Same number of steps. So it didn't really save us anything. Although, I mean, we didn't have to multiply 12 times 15. Okay. So that's your multiplication. No big deal. Like I said, this is usually either a whole bunch of A's and a few F's, or a whole bunch of F's and a few A's. The people that are ready for this one, and they're usually really ready, and it's usually a good test. The people that aren't ready, boy, do they mess this one up. All right, moving on with division. Remember, we have 3 rules that we have to deal with. No square roots. No square roots underneath the square root symbol. No perfect squares. So no perfect squares, no perfect squares underneath the square root symbol. That's rule number 1. We've been doing that, by the way. Rule number 2, no fractions. No fractions, A over B. And then the last rule is you are not allowed to have as your final answer a square root in the denominator. Those 3 rules. No perfect squares, that's the first one. We've been doing that, so you guys know how to do that one. The second one, you can't, as your final answer, you can't have a fraction. If you do have a fraction, then remember it's the square root of A over the square root of B, which could immediately lead you to the last one, which is no square roots in the denominator. All right. If you do have square roots in the denominator, then you have to rationalize it. All right, so how does this one work? Well, look, hey, the square root of 4 on the top, well, that's 2. So you get 2 over 5 root 5. Well, we're in violation of rule 3 here. So we have to do our little trick of rationalize. That just means make it an irrational number, a rational number. So let's see. We're going to multiply the top and bottom by the thing we're trying to get rid of. We're trying to get rid of the square root of 5. So we multiply the top and the bottom by the square root of 5. Final answer, that gives me 2 root 5. Maybe it's not the final answer. Over 5 times, well, the square root of 5 times the square root of 5 is square root of 25. And the square root of 25 is 5. 5 times 5 is another 25. Yeah, this one is the final answer. All right, 2 root 5 over 25. Sometimes that will be reduced, like the 2 and the 5 might reduce. In this case, no. Where did I get the 25 from? The square root of 25 is 5. 5 times 5 is 25. So there's your final answer. These can get messy, absolutely positively. All right, so that's one, and most of them will involve step or rule 3 there of some sort. All right. Let's see. I want one that reduces. Okay, this one will reduce. Okay, let's see. Step number one, if you can take some square roots, take some square roots. Simplify top and the bottom. All right, so the square root of 4 is 2. 2 times 4 is 8. And on the bottom, we can write that as 2 times. We've dealt with 12 a whole bunch of times today. 4 times 3. The square root of 4 is 2. 2 times 2 is 4. So we get 8 over 4 root 3. We can cancel here, and that gives us what? 2 over root 3, still a problem. Can't have square roots in the denominator. So we simply multiply top and bottom by the thing that's giving us a problem. What's giving us a problem is the square root of 3. Final answer, 2 root 3. 2 times the square root of 3 is 2 times the square. There's nothing to do there. Square root of 3 times the square root of 3 is the square root of 9, which is 3. Square root of 3 times the square root of 3 is the square root of 9. Square root of 9 is 3. So here is your final answer. And you can argue whether or not that looks simpler or not. I'll let you be the judge of that particular one. So final answer, 2 root 3 over 3. By the way, I'm showing you the answer here. Make sure you are, in fact, checking your answers. All right. If you're checking your answers, you will have 100% confidence that you will do well tomorrow on the test. If you're not checking your answers, well, you have no idea if you're doing these correct or incorrect. So make sure you're checking your answers. All right. Any of these look interesting? Okay, this one looks kind of interesting because it's got a negative, but there's not really much going on in this one. Is there another one that has a negative? No. All right, we'll do this one, 22. This one actually is no big deal. Notice there's nothing to reduce. Well, the problem is we got a square root of 5 on the bottom, so you're just going to multiply top and bottom by the square root of 5. That negative is still there, so we still have a negative. On the top, we have a what? A 3 root 5. And on the bottom, square root of 5 times the square root of 5 is 25. The square root of 25 is 5. 5 times 4 is 20. So we get 3 root 5 over negative 20. This is where I get a lot of people, myself included, say something to the effect of, well, it didn't seem like I made it any simpler. It looks more complicated now. And remember, the reason why we do this is so that we can do some easier common denominator. You do not want to be getting a common denominator with 4 root 5. But getting a common denominator with a 20, okay, life is a little bit easier. All right. So we did simplifying, we did multiplication, and then we did the rules for, and then this is really for division. So we did division. So the only thing left, or the second thing to the end, is adding, subtracting. All right, so let's do some adding, subtracting. Remember, you are only allowed to add or subtract if what's underneath the square root symbol is exactly the same. If what's underneath the square root symbol is exactly the same, then all you do is add or subtract whatever it tells you to do, the coefficients. So, well, what's underneath the square root symbol is the same. It's square root 24, so we add or subtract. So we got a negative 3 and a positive 2. That would be a negative 1, square root 24. I don't do anything with the square root of 24. I just rewrite it. It's the same thing as like adding, remember when you add fractions, you don't change the common denominator, you leave it the same, you just do something with the numerator. It's the same basic concept here. But wait a minute, we got the square root of 24. I know inside the square root of 24 is a 4. So that would be what, 4 times 6? This is the step that once you get really good at, you usually skip. Square root of 4 is 2. 2 times 1 is negative 2. So we get negative 2 root 6. And clearly, that's definitely simple. I mean, that took that big ugly thing right there and turned it into negative 2 root 6. So when you add or subtract, it's really easy to see the simplifying going on there. So negative 2 root 6. All right, let's do one where we don't have common denominators. Now, sometimes when you don't have common denominators, there's nothing you can do, right? Like if you don't have common denominators and you can't do anything else, well, it looks like on this one, we don't have common denominators and we can't do anything, but what's hidden inside is the potential for common, not denominators, but common radicals. So, I mean, I agree that 20 is not the same as 5, but remember, inside of 20 is a 4, So we could write that as what? 4 times 5, and you can kind of see that we're going to get the square root of 5 somehow. On the other side, we have what? 2 root 5. All right, square root of 4 is 2. 2 times not 2, but 2 times negative 2 is negative 4. So we get negative 4 root 5. Why did I put a times there? I meant a plus. Plus 2 root 5. So I'm looking when what's underneath the radical are the same. I'm just looking at the coefficients and I add or subtract them. Negative 4 plus 2 is negative 2. And then you rewrite the square root of 5. And there you go. That wasn't too bad. Like I said, sometimes you might get one where literally, like if this was a 17 instead of a 20, well, you can't do anything with a 17 and a 5, right? No, that doesn't turn into the a common radical. Okay, so that's your adding and subtract. They don't get any more challenging than that. Those are your adding and subtracting. Some of these you might subtract, some of these you might add, just depending upon what the coefficient. Remember, on this particular one right here, there's a 1. Oops, sorry, there is a, where's my pen? There is a 1 right here. And so let's see, negative 3 minus 1 is negative 4, root 45. But inside of 45, you notice there's a 9. So that's negative 4 times what? The square root of 9 times 5. Square root of 9 is 3. So we get negative 12. 3 times negative 4 is negative 12, root 5. I don't want to do all of these. I want to leave some of these for you guys to do. And I'm being very lazy today. I'm not putting many equal signs. Make sure you put equal signs. Okay. What do we got left? What do we got left? Pythagorean theorem, is that? Oh, yeah, Pythagorean theorem. All right, the last thing you need to remember, this breaks up into 3 parts here. Why are you not drawing? Draw for me. There we go. The last part would be Pythagorean theorem. And remember, the Pythagorean theorem is a squared plus b squared, where a and b are the legs of the right triangle, is equal to c squared. Once again, no calculators. You're doing all of this by hand. If you put an answer with a calculator, I'm marking it wrong, right? You need to be able to do this whole thing by hand. All right, let's see how that works. Now, the challenge here is to always find C. C is always the side that is opposite the right angle. Notice what I'm doing. I would highly recommend you do what I just did. What I just did was I drew this arrow, right? I drew this arrow, and that's pointing to the C value. So this is my C value, and the other two are your A and your B value. Okay, you don't need to label A, B, and C, but you can if you want to. So I'm going to write those numbers now into the formula. So A was 7. So 7 squared, yeah, most of you probably write 49. Plus, well, B is B, so B squared, or X squared, is equal to C squared, which is 11 squared. And yes, most of you will write 121. That's fine. Simply do the math. So that would be a 49. Well, B squared is still B squared, or X squared if you put an X. And 11 squared is 121. Now I'm just going to do a little bit of algebra. So subtract 49 from both sides. You're either going to be adding or you're going to be subtracting. When you're solving for a leg, you're going to be doing subtracting. When you're solving for a hypotenuse, you're going to be adding. Let's see. That gives me, borrow 1, 4 from 11 is what, 72. So we get 72 is equal to b squared. Do you remember b squared, or 72 before? Last step, take the square root of both. Square root of b squared is b. 72 can be written as 36 times 2. We like 72. I'm running out of space here. So let's see. B is equal to, the square root of 36 is 6. So B is equal to 6 root 2. If you tell me the answer is, I don't know, 7.8 or whatever the answer here is, a decimal, right? I will mark it wrong. You are only going to be simplifying square roots. No decimal answers for these at all. Do it all by hand, no calculators. None of you have there are some calculators that will reduce the square root, but none of the ones that you guys have. I think next year I saw somebody walking around. One of the Algebra 1 students has one of those really super good calculators that will do it. All right, let's solve one for the hypotenuse and call it a day here. All right, so there's my hypotenuse. Remember, I always do this. First step, I find C. C is the side that is opposite the right angle. So that's my C. Well, it's called A in this, or it's called X in this time. We'll call this my A. We'll call this my B, and I'm simply plugging the numbers in. So A squared is 4 squared. Yes, most of you would probably write 16. B squared is 9 squared. Most of you would write 81 is equal to X squared or C squared. It doesn't make a difference. Square both. We already said it was 16 and 81. Remember, when you're solving for a leg, you're going to be subtracting. When we're solving for a hypotenuse, we're adding. That's what, 97? So we get 97 is equal to C squared. We like those weird ones. Is there any perfect square that goes into 97? 9 doesn't go. Remember, we're going to consider the odd ones. 9 doesn't go into 97. 25 clearly doesn't. It's 49. Double 49, and that's what, 98. So that didn't work. So literally, you're lucky. Just take the square root of both sides, and you're done. So we get the square root of 97. For those of you with a calculator, and they're like, oh, I'm just going to use a calculator, he'll never know. You're going to write the answer to this one is what? 9.8 or 9.9, something like that. And then I'll know, hey, you used a calculator, right? No calculators. And yes, sometimes like on this one, you can get lucky and just have like a really weird answer. Square root of 97. All right, so I gave you an example of both solving for a leg and solving for hypotenuse. And if I remember right, that was the last thing that was on the test. I'll leave you for the rest to do by yourself. So let's see, there's 33 or 34 on the practice one. I will give you, I'll probably put 3 of these on the test. You know, either 2 legs or in 1 hypotenuse, or 2 hypotenuse and 1 leg. And then I'll have 2 to 3 on every other of the ones. Basically, it'll add up to about somewhere around 20 to 25 questions. I'll have a test posted at 7:30 in the morning. You can do it at your leisure. I will start grading on Saturday. Make sure you have it turned in. If I don't have it, by Saturday evening, I'm going to start putting zeros in the grade book. And then we will physically see each other on Monday. If you show up on Monday and you haven't taken the test, you're sucking down that 0, right? You're going to earn that 0. Do not forget to take the test. If you have any problem, like, technical problem, just send me a chat. Hey, I'm having issues, but don't do nothing, because you will get a 0. And I think you guys know who I'm probably talking about, who isn't showing up to class. You're going to get a big fat 0 on this test if you don't take it. All right, let's not end on a negative note. So let's end on a positive note. You can, guys, this is an easy test. It's an easy test. Have that resource card, use it. I expect to see plenty of A's on this test. If you do have any questions between now and the test, send me a chat or email. I'll be happy to answer any and all of your questions. I think that does it for today. I will not see you tomorrow, so it's Friday, so have a good weekend. I'm looking forward to finally seeing you. We've been a long time away from each other, so I look forward to seeing you guys on Monday. And on Monday, we literally will have 4 weeks left of class. We'll knock that out, and we'll go on summer vacation. Have a wonderful day. Good luck on your tests.